वेलकम टू आवर चैनल। इस वीडियो में हम लैपलेस ट्रांसफॉर्म की प्रॉपर्टी कवर कर रहे हैं। प्रॉपर्टी का नाम है ट्रांसफॉर्म्स ऑफ डेरिवेटिव। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए और बेल आइकन दबाना मत भूलिए। प्रॉपर्टी कुछ इस प्रकार से है कि अगर हमें x कोई सिग्नल अवेलेबल है, उसका लैपलेस ट्रांसफॉर्म गिवन है, दैट इज गिवन बाय कैपिटल X, then the Laplace transform of first derivative of x that is equal to s xs minus x with negative. So, to understand it completely, we have to prove. So, by definition of Laplace transform, the Laplace transform of d by dt of xt can be written as integration of d by dt of xt e raised to the power minus st, where the limit varies from 0 to infinity. Now, this integration can be done by integration by parts. So, we integrate it by parts, right? We'll integrate it by parts. So, in that, the formula for integration will be the integration u dv, that is equal to v into u integration v with respect to v. So, that is the formula. In our case, what is the value of u? That is e raised to the power minus st. And by derivative of this term, we have to have the du, which is given by minus s e raised to the power st dt. So, that's why derivative. Now, the dv is equal to dx, and dx, which is a function of dx, which is a function of. So, that implies that v is equal to xt. Now, by doing so much, we can calculate the Laplace transform of first derivative of x, which is equal to, now the first part, this part is calculated by putting the value of u and v, and the limit here that varies from 0 to infinity minus integration 0 to infinity xt minus s e raised to the power minus st, and dt is this, as it is the value of v. Now, after that, we can write this term by e raised to the power minus st into xt with the limit 0 to infinity minus this minus s is out of the integration. We can write it like this: minus minus will become plus. This will be 0 to infinity xt and e raised to the power minus. This portion is nothing but the excess. Portion is nothing but the excess that is multiplied by s, and this portion is nothing but the initial condition of the sequence of the xt. Now, further, this equation can be written as like Laplace transform of d by dt of x, that is equal to s excess that we get from this, and this initial condition is minus x O negative. Fine. So since excess exists, the limit t tends to infinity xt e raised to the power minus st, that is equal to 0. Only then excess exists. This is all about the first derivative. Now we can focus on the second derivative. अगर हमें डेरिवेटिव निकालना हो, सॉरी लैप्लेस निकालना हो फर्स्ट डेरिवेटिव का तो हमने कर लिया. अब हमें अगर सेकंड डेरिवेटिव का लैप्लेस निकालना हो तो हम कैसे? So for that we can write d by d square by dt square of x can be written as d by dt of means double derivative of x, that can be written. Now if it is so, and we have to find out the Laplace, so that is d square by dt square of xt can be written as sl Laplace of d by dt of xt minus d by dt of x0. So further we can write this term because we already determined this term that is given by this. So we can write that s and the Laplace transform of this term is written as s into xs minus x0 negative bracket close minus d by dt of x0 negative. Now here we can further elaborate it like s square xs minus s x0 negative and minus of d by dt of d by dt of x0. So that is what the Laplace transform of double derivative term. In that term, this term is extra. So this quantity is the derivative of xt evaluated at t is equal to 0 negative. We have to read it like this. Now, another case can come for nth derivative when you are solving the numerical. You should understand this also. Nth derivative is Laplace of the nth derivative of x fine. So that is equal to s raised to the power n. We are going to follow this equation. S raised to the power n xs minus s raised to the power n minus 1 x0 with negative. Now the derivative terms comes into the picture, that is s raised to the power n minus 2, the d by dt of x0 and so on, minus with the term n minus 1th derivative n minus 1th derivative of x0. So that's how we can calculate the derivative of Laplace of nth derivative. So you like the video, please subscribe the channel so that you can compile the new videos and you can get the notification.